Hey, good evening, everybody. We're under that northerly flow, everything moving right to left. And you notice a distinct change here. We go from these convective elements that are kind of low, a lot of fair weather cumulus earlier in that sequence, and here you see the creation of a higher layer cloud. And this is a large altocumulus layer up at about 9 to 10,000 feet. And we're just seeing the cumulus stratifying beneath an inversion up at that level. So we're going to take a look at the soundings and see if we can see that process there, because it's kind of fun to visualize stuff on the charts that you see in time-lapse footage like this. The current eclipse that we're looking at right now, there's a quick look outside. Pretty much all stratocumulus and just a little bit of low cloud right there. Little fragments and the rest of that. That's all altocumulus. And one of the symbols we use for that would be that or that. Actually, from the spreading of cumulus, there is a separate symbol, but I can't remember that offhand. In any case, let's head on to the charts here. I'm using a digital atmosphere here for the surface analysis. And you notice we get a little bit of background coloring in there. That's kind of one of the things you can do in the software. There's a map generator and there's import planetary map, which allows you to do that. So we can kind of see the terrain there. And there's all that northerly flow. And the big thing that we notice here is the lower dew points, especially up in Wichita Falls and Altus. We've got a lot of 50s dew points, very unusually low for this time of year. But ultimately, you go down to the Gulf Coast and you do pick up the 70s. So one way we can display the moisture field is by looking at mixing ratio. And there's a look at the mixing ratio plots, and pretty much just more moist as you go south towards Louisiana. And you can see little elements of bad data. So if you're doing an analysis and that's important, you can use the QC tools in the software to get rid of that. So you would go in here and look at the dew point and eventually find where your bad data is, and there it is. And you would just zero that out like that. So that's one of the benefits of using a tool like this. Anyway, let's head into, let me see if I can plot up the streamlines. That might be kind of fun here. So there it is. There's the wind flow. So Dallas getting flow from the Memphis and Little Rock area there. Whereas in the high plains, you can see the trajectories coming from Missouri, flowing up to higher elevations, and with the increase in elevation, you have a higher relative humidity and cooling, and that's a good recipe for production of clouds and convection as they hit the higher mountains there. Let's take a look elsewhere around the world. See what's going on here. We've seen a pretty good cool down in Europe, and we are looking kind of sideways here, but England there, lots of 50s, even 50s in France. So definitely a cool down in that part of the world. Also this time of the year, we see the Arctic cooling down. Usually the means in August compared to July, they lose about 5 degrees there. A little bit of bad data here and there, but lots of 30s starting to take an appearance on the charts there. And let's try going to Antarctica and see what's going on in that part of the world. Well, we don't have the polar ice pack station. Well, we got a few of them here, but the coldest temperature I can see is -85 right there. And it's hard for me to picture the difference between minus 40 and minus 85. Evidently that's significant, but I wonder if any of the old-timers down there are able to tell the difference. One area we don't look at is South America, so let me take a look at that area. Because it is the cold season in that part of the world. And they do sometimes get some very strong weather systems going through that region. So here we see Argentina, Paraguay, Uruguay, and Belize. Or, no, Belize is not that big, that's Brazil. Okay, so we plot the data. So it looks like a very cool afternoon there, very cool evening, lots of 50s on the chart. And the pattern there, much like in the Rockies, is dominated by a north-south mountain range. In this case, it's the Andes. And that tends to filter cold air northward during July and August. And there have been some very unusual events I've seen where cold air masses work their way to very tropical latitudes. And at sea level, at around 10 degrees south, I've seen temperatures in the upper 50s, and that would be unheard of in places like Panama and Nicaragua to get 50s down at sea level. But when you have a north-south mountain range like that and lots of landmass, sometimes you will get that happening there. So South America, a lot of factors, much like North America. Okay, pretty quiet around the country. The only action going on there is in the northern plains, or the southern plains, right there around Colorado. A little bit of that upslope flow hitting the higher terrain, so we have a severe thunderstorm watch box for that area. And we'll take a look at the satellite and see what's going on. We've got Franklin still spinning around down there, now starting to exit the Yucatan and get out into the Bay of Campeche, where we're expecting a little bit of development. So what we're seeing here is mostly the higher cloud layers, but you do see a few of the convective elements right in this area here, around these loosely developed spiral bands. NHC's forecast for Franklin is taking that continuing to the west. Currently showing 40 knots, so there has been some disruption from friction across that terrain there that helps the system fill a little bit more efficiently. But we're expecting definitely some redevelopment as that hits the warmer waters once again. But that's not going to be a factor here in the weather in the U.S. Okay, then we'll hit the other satellite photos, and I think one good image might be to look at the smoke. Man, we don't even have to go to the aerosol product. We can see the smoke right there. Very spectacular. Over, let me bring up the coastlines and the provinces. Just piled up there in the central valleys of British Columbia, and not hitting Oregon that bad at this point. And across the southern plains there, we can see the northeast flow pretty well. We see the cloud streets organized from east-northeast to west-southwest. And then most of the deeper convection, that's confined to the Gulf Coast region. A few good storms there around the Corpus Christi and Port Aransas area. Okay, let me take a look at the chat and make sure everything is running okay. We have Andrew here and David Moore, late night at DFW. Nice north breeze, and I'd imagine those mid-60s dew points probably feel pretty good there. We have Ryan here, breezy Sunday there in Florida, 92 degrees. Andrew spent some time outside this afternoon getting some exposure settings for the Eclipse. the partial eclipse phase. Eddie W. and Ron Chalfant are here, and David Moore asking about the rain. Fun with Tech and David and TD. Mild summer evening in eastern central Iowa, where Burl H is 75 degrees. Nice time lapse from Justin. Michael Burrell saying hello, and Mike Estwick, SPC Richmond, also joining us, and Dave Dunnett, and Ryan says the rain has subsided. Okay, are we gonna see anything on the thickness chart? Well, this time of year the patterns are usually not very strong, and usually I'm surprised if anything does show up. Usually the thickness gradients are very weak. However, we do see a little bit of troughing here in Texas, and a tiny bit of a thickness gradient in the southern plains. So for this time of year, that's pretty significant. And looks like that connects all the way up to that system off the Atlantic coast. Maybe another weak system coming out of Alberta, about right there, driven by this high over Saskatchewan and Alberta. So that would be the next system coming out of North Dakota. And way off to the bottom, we can see that Franklin is making its way out into the Bay of Campeche there. I can see one strong storm in the high Arctic. Way up to the top, there's a pretty strong thickness gradient way up here. So it looks to me like there's a frontal system about right there. So that could be one of the next Alberta clippers about to work its way southward and replacing all this warm air advection coming up the backside of this high in British Columbia and Alberta. Okay, for the SKUTs, I did do something new here. I decided to do about 4 different SKUTs, and looking at the trends also. So normally we look at Fort Worth, and Fort Worth, this is this evening's sounding compared with last night's sounding. So this is a 24-hour change. So the changes we've seen here, a little bit of cooling on the Fort Worth sounding at about 5,000 to 8,000 feet. So a little bit steeper lapse rates, and you saw a little bit more of that convection. And there's that inversion we were talking about. So yeah, we'll go straight back to this and kind of tie that together. All that altocumulus there forming underneath that inversion that we see here on the sounding. So we've seen the convection go up where we have the steeper lapse rates, and then it accumulates right in that level. So even without a salometer or ASOS, we can see that those bases are at about 8,000 to 9,000, just under the 700 millibar level. Then above that, we have the warmer air, and then when we get above about 23,000, we start to hit some drier layers. But it looks like it has humidified a little bit compared to yesterday. Okay, then a newer chart that we've not really looked at is Illinois. This is the Lincoln sounding. So this gives us a look at the Midwest, and what we see here is a lot of drying in the mid and upper levels. And we see that yesterday we had a little bit of a cirrus layer. Looking at that red line there where they come close together, that's a cloud layer, and even that has gone away. So dry air in the mid and upper levels in the Midwest. But still a lot of steep lapse rates here, so probably a lot of air mass modification still going on. So can we see that dry air? Yeah, definitely we can on the satellite loop, and we go to the water vapor, And there it is. There's that red area indicating dry air advecting southward. Then another sounding we can look at is Miami. Again, we're comparing 0Z, or 7 p.m. tonight, to the same time last night. And as we would expect in the tropics, for the subtropics, not a whole lot of change. Temperature profile looks almost exactly the same, and only very little changes in the upper levels, maybe a slight amount of drying. So your forecast here is going to go mostly with persistence. Maybe a little bit of change in the upper levels. We see some stronger winds coming in aloft there. Northeasterly flow, so if you're flying from New York to Miami, you might get a little bit of a tailwind there. But in the lower levels, not much change, maybe a slight backing of the wind right there. Okay, then that brings us to Bismarck. So there it is, Bismarck. Now probably a good thing to ask yourself is, where is that in relation to the surface systems? Well, we can go back to this chart, and this helps us figure it out. We can see that they're probably in proximity to this warm front located right here. So Bismarck located right there, warm front right through that region. So a little bit of a warm air advection pattern. And then in the lower levels, we do see the slightly increased south wind there at Bismarck. A lot stronger than yesterday. I guess we had high pressure in that area yesterday. Most of the warming has been in the upper parts of the lower troposphere, and we see that the moisture has really come up with that southerly flow. And also a little bit more moisture in the mid-levels too. But other than that, a lot of the sounding pretty much the same. Okay, so you can do that with your soundings too, and it's pretty easy to do. You just go and go to these sounding sites. University of Wyoming is a good one. You just use copy image, and you copy it and paste it into PaintShop Pro or whatever your favorite program is. And then the trick is to, I'm just mixing this up just for demo purposes, but what you're going to do is you're going to use edit and paste the new layer. And then that gives you two layers here, and then you have to combine them using one of these layer mixture tools. And then you have to colorize one of the other layers. So that's pretty much all there is to that. Or you can use a tool like Rayab that lets you compare the soundings. Okay, let's see what else is happening. 250 millibar chart showing a little bit of ridging building in across western Canada, so that's definitely not good for the wildfires there. We do see a medium wave trough coming down from Alberta, so that's supporting that system that we have at the surface right in that area. We see a medium wave ridge coming through around Minnesota and Nebraska, and then we have the next downstream trough across the eastern portions of the Midwest, and then over the Maritimes and New England, yeah, we do have that departing jet right there. So relatively simple pattern, and we see it right here. Trough, trough, ridge, and then there's a flat ridge somewhere out here, and then another ridge way off in Alaska. So depending on where you are, this kind of establishes your weather regime. So you're going to expect to see some good weather around Chicago, and maybe a little bit of deterioration around Rapid City and Bismarck there. Okay, let's see if we can see the fronts on the thickness chart. Actually, this isn't thickness, this is potential temperature. And I'm using this kind of as an alternative to surface temperature. Yeah, we can definitely see a front coming south through Montana there. And perhaps there's some support for a front right here. Maybe a warm front. Out over the Lake Superior, right around here, that could be just a lake effect, cooling there, affecting the readings. Definitely that problem along the west coast, so you do have to kind of be careful with this data. And it helps more to compare this from day to day. I do think in Colorado and New Mexico we've had these fronts moving south through Texas and the Gulf Coast. And obviously the tail end of those fronts, they do tend to pile up in the Rockies. And I think that's what we're seeing here with this gradient. I think these are the fronts kind of piling up there in Colorado. Potential temperatures definitely a lot warmer out around Grand Junction and the Four Corners than they are in Colorado, where conditions are kind of mild. So I think the graveyard for these fronts has ended up in that New Mexico, Colorado area. So that will probably kind of affect the weather there over the next day or two. And that's probably helping to generate some of this convection that we see, especially up in Colorado. Okay, let's see here. What's up next? I think that brings us to the models. Maybe I'll leave this up and you can look at Franklin there, and I'll take another look at chat here. A little bit quiet in the chat room, though we've got a pretty large crowd. 66 there in Denver. Yeah, very mild there from Mike Estwick. Ron Chalfant reminds us, don't forget the like button. And that's appreciated. I believe that helps our rankings on Google or in YouTube. So that will definitely benefit us. Mild summer evening, 75 degrees there in central Iowa. Okay. Let's head into the models here. I'm going to take a look at starting out with the mesoscale. So I like to use the high resolution rapid refresh for that, since we're just looking at, just kind of a general picture of what's going on. There's the thunderstorms in the Clayton and La Junta area. We're going to see those move into the Texas Panhandle and the Oklahoma Panhandle also during the overnight hours, and those will subside. A little bit of a tail end area coming along and just west of Amarillo there. So probably plenty of opportunities for lightning shots west of Amarillo. And then those subside after dawn. And then we're left with high pressure, just continuing to pump this cold, well, not cold, but this drier, milder air southward. And then we'll switch over to the NAM and see what that shows. This is the composite reflectivity. This is kind of like simulated radar. So we see overnight, there's those storms there in the panhandles. Those die down around dawn. And then the NAM goes for some regeneration right there west of Great Bend and Wichita and Pratt. Then for tomorrow, peak heating. Not much going on except in Minnesota along that front that's coming southward out of the Dakotas. The usual activity down in the southeast U.S. And then pretty quiet for Texas. Then the next day, for Thursday, looks like a MCS coming southward. And the models have been indicating that. We saw that last night. And that brings an MCS southeastward through Kansas and all the way to Oklahoma by morning. And that's a pattern straight out of the 1996 playbook, when we had a very strong Hudson Bay vortex. I think there were about 10 or 20 nights in Oklahoma City where we had these MCSs rolling southeastward. They would develop near Denver, move through Kansas overnight, and end up in Oklahoma City by dawn. Okay, then just kind of a general look at the GFS. Well, there's that northeasterly flow. So here comes the next wave, moving slowly southeastward into the Great Lakes by Thursday. Not much change except for the development of this area of strong jet stream winds over the central U.S. So that'll help augment the thunderstorm activity, especially as we get into Thursday night. And then when we get into the weekend, jet stream moves into the Midwest, so precip chances will be going up for that area of the country. Then we see the subtropical high trying to build into Texas a little bit, so maybe a little bit of warm weather trying to settle in. Although that depends on whether we get another cold front making its way south. And then we just kind of continue with northwesterly flow here in the U.S. And then a little bit of troughing around the eclipse time. See, the eclipse is now starting to come within range of the models, and they're looking for a trough to the west and a ridge to the east. Okay, so that's the 200 millibar chart at the time of the eclipse. So trough out here and a ridge over the central U.S., and looks like another trough off the east coast. Now, one way we can look at the certainty of this is to look at an ensemble. And one good ensemble to look at is the North American Ensemble Forecast System. This combines the GFS and the Canadian models. And let me see if I can find a chart that I've got prepared here already. Okay, yeah, here's the 200 millibar chart. This is up at 40,000 feet. This is on the morning of the eclipse. And what you see here is a variety of different solutions for North America from the Canadian model. So here's run 1, here's run 2, run 3, and they adjust the models in different ways and rerun it and try to see what kind of solutions they get using the same base data. And for example, we see on this ensemble here, a very strong jet stream across Nevada. This ensemble has a strong trough over the west coast. Very strong jet stream winds over Oregon. We have this other ensemble that does the same thing, but it's got everything a little bit weaker. And kind of the same thing with a lot of these models, like this one. And then this ensemble here, a little bit different. So what we can do is we can kind of combine all these and look at the standard deviation, and which is kind of like a measure of the error. And we can go for a mean of the jet stream winds. So here, this is looking at the expected jet stream. Now the shading is going to correspond to the error. So there's a fairly high certainty that we're going to see strong jet stream winds just off the coast of Washington and British Columbia. Maybe something like that. We don't really know the direction. However, you can see the red in here indicating that there is not much confidence in that. Let me run this back here and I'll show you how this comes together. In fact, let me see if I can bring up a height field here. Let me bring up geopotential. This will show us kind of like pressure. Okay, so we're looking at a forecast for right now. So all the models, they pretty much agree on this. And if you look at the individual members, they're all pretty much showing the exact same pattern because this is very easy to forecast. This is just like a 12-hour or 24-hour forecast. However, as we go further into time, there's the forecast for the 10th. There's the 11th. And there's the 12th. And you can see the error starting to creep in. The purple is indicating uncertainty there. And as we go up to the 13th and 14th, the differences in all the ensembles starts to vary more and more. So a lot more disagreement with the fields along the west coast. Some of the models going for ridging, some going for some troughing. And then by the time we get up to the eclipse time, there's the 19th, 20th, and 21st. Some of the biggest disagreements are just off the west coast there. And if we look at the individual fields, this is for the eclipse morning. And it does look like there's a strong tendency for some troughing off the west coast there. But some of them are placing the west coast in an area of jet stream activity. Some are going for some ridging, slight medium scale ridging right there. And look at that right there, some big ridge across the British Columbia area. But it looks like the majority of these have some ridging on the west coast. So I think we do have to kind of take that into effect. This is the GFS portion of the run. That also is going for some sort of troughing right off the northwest coast. But I think a lot of the disagreements in the fields here are more related to the magnitude of that height field. So I think probably what we're looking at here is a trough somewhere in the Pacific Northwest and probably a ridge in the central U.S. See, I'm looking at all the member fields here. Yeah, it does look like the majority of these have some ridging. This one is a lot different, for example. So this is where we have some disagreement. This one going for a big ridge off the west coast. So this is kind of how we go through the ensemble fields. And just taking a look at cloud cover, and there was one user here that pointed this out on the College DuPage site. This is for the 21st here. And this is the current forecast we have of cloud cover at the eclipse time. So the eclipse is running a track like this here. So this is showing that perhaps some of the strongest problems are going to be in the northern plains, the high plains, the Great Plains itself, the lower plains and Midwest looking good, and then they put a lot of cloud material in the Appalachians, and that is one area that I've been concerned about for quite a while. However, if we look at previous runs, like last night's run of the GFS, Take a look at the difference here. Okay, so it looks kind of similar. Clouds in the Appalachians, clouds in the high plains. But we go back to the next run. Okay, so the placements are a little bit different. Then we go to the previous run before that. Okay, so now it's moved all the clouds into the Midwest. So this kind of shows you how much uncertainty there is at this point. Okay, so we're just going to have to wait for a few days to kind of wait for the models to kind of converge on a solution. However, this idea of cloudiness or of low pressure off the west coast, low heights off the west coast, I think there is some consistency with that, so we're going to have to keep an eye on that. We're probably going to be looking for some ridging over the Central Plains. But aside from that, we really don't know. Now, one other way we can look at the cloud cover here is to look at relative humidity. Okay, so looking strictly at this cloud solution here, clouds over Wyoming, clouds over Denver, and over the Appalachians, we'll look at the 250 millibar relative humidity. This is up at about 34,000 feet. So we can see a lot of high humidities up at that level. So this is probably consisting of a lot of cirrus, for example. And looks like the same thing there in the Appalachians. 18,000 foot relative humidity looking like this. Okay, so pretty much the same thing. Looks like some deep cloud layers. This might indicate convection. 10,000 foot relative humidity. Now you see a lot less relative humidity right here. So again, this is probably indicating more high cloud. However, this indicates probably some deeper cloud layers. And then down at 850 millibars, which is about 5,000 feet. Here we see a lot of the tropical moisture covering the eastern U.S. So probably some stagnant weather patterns, a little bit of lift along the mountains and the Appalachians. And probably what we're seeing here is a little bit of anvil cloud with some of the deeper convective development in that area. And again, this is just kind of like a first glance at what might be happening. A lot of disagreement with the models at this point, and we're going to have to wait probably till about the 12th to the 14th before we start getting a solid handle on what's going to be happening. Let me bring up some preset products. For we'll try the sea level pressure and precipitation. So this is, again, is at the eclipse time. The current GFS is going for a bit of rain right there around Chattanooga, around the Knoxville area. Looks like some sort of frontal boundary through Texas, and then some ridging building into the Midwest. So that's helping to keep the skies pretty clear in that area according to this run. But if we compare this with other runs, going back to last night and the previous day, let's see what kind of differences we get here. Yeah, much different solution here. We got more of an MCS in Louisiana. We go back another run, much different. A lot of Gulf Coast and Florida stuff. So you see how much variability there is from run to run. So, yeah, we just don't know. There has been consistency, though, with Idaho looking good. So I think they may luck out. We'll just have to see. All right, let's see here. One last look at chat. I think either I'm not seeing too much message traffic here. I wonder if my chat is not updating very much. David Moore says, got to run. Thanks, Tim. Good night. Thanks, David. Sarah Wood joining. Terry H. says, hello from Nebraska. And that Terry H. from Nebraska, that's the last message I'm showing here. I'm going to try updating my dashboard here. This is what I'm looking at. So I'm going to refresh that and see what happens. You can see I'm getting this message here about video output being low. Hopefully y'all aren't seeing any buffering. Okay, it's come up green, so we're looking good. Okay, I guess, yeah, here we are. Ryan, adding tropical wave EV11 impacting South Florida on Thursday evening into Friday this week. Okay. All right, guys, I think that's about all I have for tonight. I appreciate you watching the webcast, and we'll continue taking a look at the eclipse as the week goes on. We'll start looking for these models to start converging. And then we'll have a forecast for you as soon as we have an idea what's happening. Anyway, have a good evening, take care, and we'll see you tomorrow.